Hi everyone, welcome to my channel. So this is a LeetCode question 142, linked list cycle 2. Given the head of a linked list, return the node where the cycle begins. If there is no cycle, return null. Okay, so first let's look at some examples. Okay, so in this example, it should return 2 because there is an intersection, and we will return the node at the intersection. And in this next example, it should return 3 because that's where the intersection is. And if there's only one node, that means there's no cycle, so it will return null. If there's no element in the list, then it will also return null because it can't have cycles. And lastly, if there's no cycle, then it will return null. So in this problem, there are two parts. So first we need to find, or we need to check if there is a cycle. And then if there is a cycle, we need to find the intersection. So first step, check if there is a cycle. So to do that, we can use two pointers. We can have fast pointer, we can have slow pointer. They both start at the head, but the fast pointer moves by 2 and the slow pointer moves by 1. So why we do that is if there's no cycle, then the fast pointer will eventually get to or reach null at the end of the list. If there's a cycle, they will eventually meet. So if there's a cycle, let's see, so the fast pointer moves by 2, so here, and slow pointer moves by 1. So we will do that until slow pointer is here, and we'll do that until they eventually meet. So we can say that if they meet, there's a cycle, and that's the first step. And second step was to find the intersection. So as you can see, the distance from where they meet, where the two pointers meet, to the intersection, in this case, is 1. And coincidentally, the distance from the head to the intersection is also 1. So let's see if that's the case for the other example. So in this case, if you traverse the fast and slow pointers, they will eventually meet right here. Okay, oops, let me fix that. And the distance from where they meet to the intersection is 2, 1 and 2. And the distance from the head to the intersection is also 2, 1 and 2. Okay, so now we know they are the same. Next thing we can do is move one of the pointers back to head, and then we can traverse both pointers by 1 this time. So if we do that, let's see what happens. So slow pointer moves by 1, fast pointer moves by 1, so that's one operation. And let's do that again, and they will eventually meet again, and this time they will meet at the intersection. So that's pretty much how it works. And we can also prove this mathematically. So let's see. Let's look at this example again. Okay, so let x be the distance from head to the intersection. So in this example, this will be x. and let y be the distance from intersection to the meeting point, so where the 2 pointers meet. So that will be here. And let z be the distance from the meeting spot to the intersection. So in this case, this will be z from 4 to 2. So using those variables, now we can calculate the distance the f travels and also the distance the s travels. So the distance the f traveled to get to the meeting spot is x plus y plus z plus y. And the distance the s travel to get to the meeting spot is only x plus y. Since the f or the fast pointer traverses twice as fast, which means the distance the f or fast pointer traversed is also twice as much. So from that we can say we can multiply the distance the s traveled by 2, and that will be equal to the distance the fast pointer traveled. So using this, we can just this is simple algebra. So this would be 2x plus 2y, and 2y cancel each other out, and then this will become x equals to z. Again, x was the distance from the head to the intersection, z was the distance from the meeting spot to the intersection. So we just proved that they are the same. Okay, now let's actually write the solution. So first we have to check if there is a cycle. So to do that, we'll use 2 pointers starting from the head. So slow pointer from the head, fast pointer from the head. And we will loop through the list. And we are going to check if the fast pointer is null or isn't null, and also a fast dot next pointer isn't null. That is because the fast pointer traverses by 2, so we have to check the next pointer as well. So as long as the fast pointer doesn't reach null, then fast traverses by next dot next. Slow pointer is just by 1. And then we can check here if fast and slow are at the same node. That means that they met, and that means that there's a cycle. So we can break. And if there's no cycle, then the fast pointer will eventually gets to null. So we can check that down here if fast is null, or first fast dot next is null, then there's no cycle, so we're gonna return null. Okay, so we checked if there's a cycle, and if there's a cycle, we said that we will bring one of the pointers back to the head, and then as long as the slow and fast pointer doesn't meet, so we can stop when they meet because we know that they will now. They are going to move one by one. Fast dot next, and then we can just return one of the pointers because it will be at the intersection. So let's see if this works. Alright, so yeah, this was the LinkedList Cycle 2.